The purpose of a chi-square goodness of fit test is to decide whether the distribution for a categorical variable matches what we would expect that distribution to be. So in the problem here on the screen, we're told that a company has collected data to determine whether or not its employees are more likely to be absent on some weekdays than on others. So they looked at a sample size of 140 employees. What we expect to be the case, it says here, that the first row shows the distribution from the sample across the 5 days. It says the second row in the table contains the expected frequencies if absences at the firm are equally likely on each of the 5 weekdays, which means that 20%, right, for each of the 5 days. So 100 divided by 5 is 20. So our first job is to calculate the missing expected frequencies that are in the table. And we just want to check here, it says round your responses for expected frequencies to 2 decimal places. So we'll go ahead and do that. To calculate the expected frequency, we just multiply the percentage, so 20%, times the sample size. So our answer here for expected frequency is 28. And you can see it's actually going to be 28 across each day because each day is equally likely and the sample size never changes. In most problems that you're going to get, though, it will give you different percentages for each of the levels of the category. So you might have gotten a problem where it would say, for example, it's 10% on Mondays and 30% on Tuesdays, etc. Our next task is to fill in the values in this final row of the table, and the problem says to round those to at least 3 decimal places. And the formula is actually given right there for you. So in this case, for this first one that we're going to fill in, it's 34, the observed frequency, minus 28, the expected frequency. Square that value and divide it by the expected frequency. 1.286. Down here for Friday, we want to calculate 41 minus 28, square that value, and divide by 28. And we will get 6.036. Down in table 2, we're asked to test a hypothesis. So in this case, the null hypothesis is that employee absences are equally likely on each of the 5 days. And the alternative, or the research hypothesis, is that there's 1 or 2 days where absences are more likely than others. So the type of statistic we're going to use here is a chi-square. And the degrees of freedom are the number of levels in your categorical variable minus 1. So in that case, it's 5 minus 1, or 4. And we have to calculate the test statistic, but actually that's pretty easy in the problems on ALEKS. We just need to add up all of the values in this bottom row of table 1. So 1.286 plus 6.036 plus 2.893 plus 0.321 plus 6.036 is going to be 16.572, and it says to go to 2 decimal places only, so 16.57. And then it says the critical value for the test at 0.1 level of significance. So we want to come over here to use the chi-square calculator at a 0.1 level of significance with 4 degrees of freedom. Our value should be 7.78. Can we conclude that the absences by the firm's employees are more likely on some days of the week than others? And so what we're testing for here is whether our calculated test statistic, or chi-square goodness of fit test, is larger than this critical value, and it is, so we can say yes.